Right. Very good evening to one and all. Sorry. Very good morning to one and all. And we are going to take the same session as we discussed yesterday because yesterday, due to some network issues, we couldn't complete that. Yes, so we can continue with the yesterday session and also some new topic in this today's session also. So we can look into it as a short brief, right? So what is we just started with avalanche effect in that last class, right? So we have just started with that avalanche effect. What is mean by that avalanche effect? It is a simple one. Is there any change in that plain text and any change in that key? It will resembles in our ciphertext. Okay, so this is known as avalanche effect. This is a very much important 2 mark question from your second unit, right? So avalanche effect is nothing but is there any change in that plain text or any change in that key? That change will resembles in your ciphertext also, right? And after that, we have seen that the strength of this. Okay, so we have seen that what is the purpose of this and what are the applications. I mean, what are the applications in that disk and what is the functionality in this disk operations. Okay, we have already seen that, right? So what is the strength of disk? It is just a continuation of that disk question, right? So first thing is the main strength of the disk is size of the keys. Okay, so why? Because the size of the keys will be 56 bits, right? So that 56 bits keys will work for that conversion of that plain text into ciphertext. Okay, if that intruder breaks that message, means if that intruder get that ciphertext, means he can try to get back that original plain text, right? So for that retrieving function, he must use all the possible keys. Okay, all the possible keys. But in our case, we have 56 bit keys. The size of the keys is 56. So the possibilities are almost 2 power 56. Okay, so 2 power 56 means it will come to some infinity numbers, right? So each and every number he must use. It will take a more time. Okay, so the intruder will not be able to get that original plain text as much as easier one, right? So it is somewhat tough, it is somewhat very tough to that particular intruder. Okay, so this is the main strength of the disk. And second one, brute force attack. What is mean by the brute force attack? Trying all possibility keys to get that original message. Intruder can try all the possibilities of keys. That is known as brute force attacks. All the possible choices, all the possible ways, right? But here, as we already told, here we have 56 keys, so 56 bit keys. So 2 power 56 possible keys he must try. So brute force attack is not at all possible in this disk, right? So this is a second strength of the disk. And the third and very much important one is we have several alternatives for this disk, right? We have seen some single disk only, right? We have double disk functions and also triple disk functions, right? So for the double disk functions, we have 16 rounds in that single disk now. So for the double disk, we have almost more than 20 rounds there. And for the triple disk, we have more rounds comparing to single and double. Okay, so these much rounds are taken place to create or to generate a encrypted key, right? I mean, to generate a ciphertext, right? So this is one of the important strength of disk. And what we have seen next one is differential cryptanalysis. Okay, so what is meant by the cryptanalysis? Cryptanalysis is nothing but a study of breaking the ciphertext into that plain text by an intruder. This is a cryptanalysis. Cryptanalysis is a function. Okay, so the function which was done by that intruder, he is known as cryptanalyst, right? So cryptanalysis is nothing but retrieving that original message from that ciphertext by an intruder. This is a process, cryptanalysis, right? And here we have two types of cryptanalysis in here, right? So first one is differential cryptanalysis, and the second one is linear cryptanalysis. So what is meant by the differential cryptanalysis is it's a general form of cryptanalysis. There is no there is no inside thought. There is no any other functions inside it. It's a somewhat a general form, right? So this general form will be highly used in block ciphers. Okay. So what is meant by block ciphers? Again and again, I'm telling what is meant by block ciphers. We can take some more than one data to encrypt at a particular time. This is known as block cipher. What is meant by stream cipher? Only one data will be taken for encryption, but block ciphers means more than one data we can take. Okay. Yes, for the block ciphers, this differential and cryptanalysis is highly used. It will be used for stream ciphers and also hash functions, but it will give more priority to block ciphers. Okay, so this is known as differential cryptanalysis, right? So what this cryptanalysis performs means it was a registered idea. It was a registered or a published idea. It was a this idea was published by one of the corporate companies which was working under that cyber security, right? So the differential cryptanalysis is a published attack. It was registered, right? Here, this 2 power 55 encryption possibilities are there, right? For why this 2 power 55? Because I'm using some 56 bit keys. For that 56 bit keys, I want to generate. I want to take some 2 power 56 values to get the original one, get the corrected one, right? So this is a differential cryptanalysis. And next one is linear cryptanalysis. So what is meant by that linear cryptanalysis? This attack is based on linear approximations. It's mainly focused on that linear approximations. Approximations, okay? It's just an assumption, okay? So I can take that cipher text, okay? So once if I send a message to you all people means if I send a message to you all, but it was encrypted with some other ones. Okay, it was encrypted, so it cannot be able to open some other third parties except you. Right here, I am a faculty from that IT department, and I am the faculty who is taking cryptography and network security subject. So some third persons may assume he sends the data which denoted some concepts in that CNS or which denoted some concepts, I mean some information from that IT department. They can assume, okay. So based on that assumptions, they can try to retrieve the document, right? This is a linear cryptanalysis. It perfectly based on that approximations, okay, right? So these are the two types of cryptanalysis here. And next one is block cipher design principles, right? So what is the design principles? What is the principles behind the designing of block cipher, right? In our we can take from the DES application itself, DES algorithm itself. Okay, so we have almost on three critical aspects, right? So what are those three critical aspects? First one is number of rounds. Second one is design of a function f, and the third one is key scheduling, right? So we have some three critical aspects here. First one is number of rounds. So number of rounds is differ from various. I mean. Which differs from that various dysfunctions, right? So already I told now we have three types of disk: single round, double round, and I mean single disk, double disk, and triple disk, right? The number of rounds will be differ for these three things. Okay. So for the single round, it has around 16 rounds, and for that double disk, the rounds will be increased. The rounds will be more than 20 rounds, right? And for triple disk, the rounds will be differs. Okay. So this is the first important aspect in that designing principle. And what is the second one? Designing of a function. Okay, so in this disk we have used some two functions, right? So what are those two functions? One is permutation and another one is substitution. Why we have used that permutation? What is the purpose of permutation? Permutation is used for how to say permutation is used for getting the choices from the key, right? You just imagine the diagram, imagine the general form of the disk, general architecture of disk, okay? So we have certain key value, that is 64 bits are there. So after that key, it performs that permutation choice function, permutator choice 1 function. Okay, so what is permutator choice 1? From that 64 bits, I can take only 56 bits. How I contracted the, how I compared that, compiled that. How I compiled that from the 64 to 56, I've deleted every 8th element of that particular bits, okay, particular key, right? So the 64 is converted into 56. This is the function which was taken place by the permutation, right? And the second, the permutator choice 2 also will be there. There, 56 bit is converted into 48 bit. Again, the same function happened. Again, the same thing, a deletion of every 8th element. Okay, so this is known as permutator choice 2, right? And another function, that is substitution function. What happened in the substitution function? What is the purpose of the substitution function? It just compiled again, it just compiled that 48-bit data into 32-bit data. How? It has used some S boxes. Okay, so what is the function of S boxes? We have 8 S boxes in that substitution function, right? So each and every substitution boxes, each and every S boxes got input as 8 bits, got input as 6 bits and produced output as 4 bits, right? So, how that 8 has converted as into a 4, sorry, how the 6 is converted into 4, I just delete that first and last bit of the input one. So, what is the name of that first and last one? Row bits. And what is the name of the middle bits? It's a column bits, okay? I have deleted row bits, I have deleted row bits, okay, in each substitution box, each S boxes. So for one box, I've got output as 4. So totally I've 8 boxes. So total output will be 4 into 8, that is 32 bits. Like this, that 48 bit is converted into 32 bits. This is another function we have used in that base. Okay, so this all comes under this design of a function F. And the third one is key scheduling. Key scheduling plays a very important role in this days. We have another concept called key management. We'll look into it in that from our third unit. It will be more interesting. Key management is a more interesting one and also more important one in your university exams, right? So before that, we will look at key management concepts in our third unit, right? So now key scheduling. So what is the purpose of key scheduling? We have 16 rounds and we have keys are there, and that that key management must allocate particular key for each and every round to perform along with that plain text. Clear? So till a round system, the key must be produced for each and every round. We must allocate the key for each and every round. Okay, this is known as key scheduling. So these three are the very important aspects in your block cipher design principles, right? And so this is somewhat brief about yesterday's session, and now we are going to see something important, something about block cipher modes of operation. So it is also an important 8-mark question from your second unit. Okay. Okay. So block cipher modes of operation. So what is mean by that block cipher modes of operation? What is the purpose in that? Okay. So we have certain operations. We have some different kinds of operations by using this block ciphers. Okay, so what are the different kinds of operations? We'll look into it. Okay, the first point, encryption algorithms are divided into two categories based on that input as block cipher and stream cipher. Already we have told, for stream cipher I can take each and every bit individually for encryption. For block cipher, more than one data I can take for encryption. I can take for encryption, right? So these are the two types. And second one, block cipher is an encryption algorithm which takes fixed size of input, say, okay, fixed size of input. So this is also one of the examples of block cipher, okay, and I have taken some 64 bits only, not more than that. It's a fixed size input, right? So the block cipher encryption method will get only fixed size of inputs. It may be a 64, it may be a 48, it may be a 32, anything. So in this operation, I have taken that 64 bit. It's a fixed one, right? Okay. So if input is larger than bit size, it can be divided further, right? So if the input is more than 64 bits, okay, so I have a data which was more than 56. I need to encrypt the data by using the disk. Now, what happens means if my data is 128 bits, I can segregate or I can divide it into two things, 64 bits and 64 bits, right? I will perform some disk operation for the 64 bits individually. On the same thing, I can perform some uh, individual disk function for this remaining 64 bits. Clear? Okay. So this is known as, this is the main concept in a block cipher mode. Next. So these are the five standard modes in our operations. Okay. So modes of operation. We have five types, right? So first one is electronic codebook, cipher blockchaining, cipher, excuse me, cipher feedback and output feedback, and the last one is counter. So these are the five standard modes of operation, five types of operations. First one is electronic codebook, cipher blockchaining, cipher feedback, output feedback, and counter, right? So what is meant by electronic codebook? First thing, electronic codebook is the easiest block cipher mode. Okay, so it is a first part. It is a first stage of block cipher modes of operation. It was a first operation in that block cipher. Okay, so it will be more easy, right? We'll explain by a diagram. Okay, so before that we can look into the advantages and disadvantages of electronic codebook. Okay, so first advantage is parallel encryption of blocks of bits is possible. Okay, so what is the parallel encryption? Parallel encryption means, so we have seen that in that last slide itself we have seen some function. Now if that input is more than that fixed one, I can divide it into two, and these two functions will be worked. Two functions will be taken place parallelly. Okay, so this is a advantage of electronic codebook. Second one is simple way. It is a very simplest way. Okay, so what is the disadvantage? It's prone to cryptanalysis. So for that cryptanalysis, it will be easily compromised. It will be easily compromised by using ECB, I can generate ciphertext, but it will be easy for the intruder to retrieve that, right? So this is one of the disadvantages of electronic codebook, right? So now this is the diagram for that particular electronic codebook. Okay, so I have a plain text. Okay, that plain text, I have a plain text of let me take some 128 bits plain text. Okay, so I have a fixed one only, not in the disk. I have a fixed input as electronic. As the principle of block cipher mode, it will take only the fixed inputs, and the fixed input also will be under 32. For example, under 32 bits. Okay, so but I have 128 bits of plain text to encrypt. So that 128 bits will be divided into some parts, and each part will be contains 32 bits. So how many parts will be there? Almost four plain text. The single plain text will be divided into four parts: P1, P2, P3, P4, and each P1 has 32 bits, P2 has 32 bits, P3 has 32 bits, and also P4 has 32 bits. Clear? Okay. And I can encrypt so I can encrypt that particular 32 bit, okay, by using key, right? After encryption takes place, it will produce ciphertext. I can name it as C1, okay, ciphertext C1, C2, C3, C4, okay. So after getting all the ciphertext, I can conclude, or I can attach these separate outputs into a single frame, into a single output. Okay, so I can combine C1, C2, C3, and C4. What is C1? Ciphertext from that plaintext 1. C2, ciphertext from that second operation. C3, ciphertext from that third operation. C4, ciphertext from that fourth operation. These four operations will be taken place parallelly. Okay, so note it down. This will be taken place parallelly. Right. Okay. So the decryption also, it's a vice versa of encryption. I can segregate the ciphertext into some parts, and I can decrypt by using the same key. Okay. So I can decrypt my data. At last, will get that original plain text. Clear? So this is a function of electronic codebook. Right. Next. Cipher blockchaining. So what is Cipher blockchaining? It is somewhat an advanced version from the ECB, that is electronic codebook. It was because ECE is a basic one. I mean, electronic codebook. ECB is a basic one. Okay, so we have seen that disadvantage. What is the disadvantage we have seen? It is easy for cryptanalysis. Okay, so to avoid this, I need to upgrade my ECB. Okay, the upgradation of ECB is nothing but Cipher blockchaining. Okay, it is somewhat advanced version of that ECB we can take. Okay, so first point itself we have seen. In the first point itself, this approach overcome the security deficiency. So what is a security deficiency? It will easily compromised with that intruder. That is a main security deficiency. Okay, to avoid this, we can move. We just moved for that Cipher blockchain concept. Okay, right. So what is the what is the advantage here? CBC works well for input greater than B bits. Okay, so B bits is a fixed one. Fixed one. It may be a 32 bits, it may be a 64 bit, or it may be a 128 bit. Okay, but it may be 128 bit. This CBC Cipher blockchaining will work well for that inputs which was greater than B bits. Okay, so if the given bit is more than the fixed size, this we can use this Cipher blockchain. Okay, and second advantage is CBC is good authentication mechanism. It is a good authentication mechanism. What is an authentication? What is an authentication? We have seen in the first unit itself. What is an authentication? Can anyone tell what is an authentication? Yes, anybody? Or shall I tell any name?
So provides identity to the user, sir.
Yes, it's a provide identity to the user. Okay, that for example, if I send a message to you all, you must believe this message was sent by Praveen only. How can you confirm this message is from Praveen? By look into my mail ID. So my mail ID is a authentication for you that this message was sent by Praveen. This is known as authentication. Very good. Okay, so this is an authentication. This authentication will be very good in the Cipher blockchain, right? And what is the third one? Better resistive nature towards cryptanalysis. Better resistive nature. What is that resistive? What is the meaning for that resistivity? So not in our subject. What is the general meaning for this resistivity? Anybody? I just need some general meaning for this resistivity. So a lot of people are telling my phone is a water resistant, my watch is a water resistant. What is that? If any problem occurs or if my watch drop into water, it will be resistant. It will how to say? It will not get any effects. It will not get any effects from that water. So that is resistivity, resistance, right? So here the resistivity nature. What is that resistivity nature for? How to say? If my cipher text got by that intruder, it will get some more resistivity. That is, it will hold the privacy or it will hold the security better than an ECB. Okay, so better than an electronic code book, right? So these are the advantages of Cipher blockchain. And what is the disadvantage here? Parallel encryption is not possible. Okay, so why the parallel encryption is not possible? Every encryption requires previous cipher. Okay, because in our ECB we have seen all the things will be taken place parallelly. P1 will be taken place parallelly, P2 will be taken place parallelly, and each will produce output parallelly. Each will produce output parallelly, and that output will not insisted in any other functions. All the four parts will be acted independently. right? But here in this cipher blockchaining method, in this cipher blockchaining, the first output will be an input for the second one. So the second operation is depends on that first operation. For example, E1 is here, and so we are doing some XOR function, and after XOR function, I got some plain text. So that plain text will be encrypted by key. After encryption, it will produce cipher text. This cipher text will be an input for the second one. Okay, so plain text 2 will be XORed with that cipher text of the first one. Okay, it's like a loop. For the first one output will be an input for the second one. Okay, so it will works as a serious one. Okay, so first one, after completing the first one, we go for the second one. After completing the second one, we'll go for the third one. Okay, so this is known as cipher blockchaining, and this is the difference between a ECB and CBC. Okay, I think you got clear idea, right? And the third one is cipher feedback. So cipher feedback. What is the advantages of cipher feedback? Since there's some data loss, yes, almost time. Since there is some data loss due to use of shift register, thus it is what are they doing? Okay, so if the data lost due to that shift register, it will be difficult for applying cryptanalysis. For example, this is a diagram for this cipher feedback, right? So nonce is a key. Okay, nonce is a randomic number. So nonce is nothing but a different one. It's a randomic number, right? I can take some randomic number and I can encrypt that randomic data by using the key. I will perform with that plain text. I can perform XOR function with that plain text. So after that, I will get some output, right? Clear? Okay. So it will be different from previous two, right? So here some nonce is a function, nonce is a randomic number, right? So I can take some randomic number and that randomic data, okay, randomic number or randomic data, okay? So I can take that randomic data and that randomic data will be encrypted by using that value k, that is by using the key k. After encryption, it will produce some output. With that output, I will do XOR function with plain text, okay? Plain text 1. So I'll get some cipher text here. The same process will be continuous, right? So this is a cipher feedback, okay? So what is an advantage? Shift register. Due to, since there is some data loss due to use of shift register, thus it is very difficult, okay? So here, the intruder cannot able to know what is the randomic number they have taken, right? That's the one. And that randomic number, after encryption also, the encrypted data, that encrypted number will send to P2, send to second function as an input, right? Okay, so here the intruder cannot find what is the randomic number we have used. So it will be more difficult to get the original data by the intruder, right? This is the advantage of cipher feedback. Okay, and the next one is output feedback. So output feedback is a very simple one. It's similar to the CFB, that is cipher feedback chaining. Cipher feedback. Okay, so like a cipher feedback, output feedback also will performs. Okay, so here we have only two formulae here. So CJ is nothing but a cipher text. So how can I get the cipher text? Doing XOR function with that plain text and this equation. Okay, so I can explain this equation. So Cji minus 1, Pji minus 1. That is the cipher text which was got after the performance, after the encryption takes place by the Pj minus 1. That is previous data. Okay, so that encrypted data will be again encrypted by using the key value. Okay, so at last I got some encrypted message. Along with this encrypted message, I can do some XOR function with my current plain text. I think you got it. If any doubt, you just ask me now. Okay, so this equation is nothing but Cj is a cipher text of J. For example, we can name it as C1. Okay, so C1 is the current one. This current one, I want to get a cipher text for the current one. For that, I'm doing function for P1 along with that XOR function. I mean P1 with that encrypted data. Okay, so I got P0. I mean C0. C0 is my previous function. How I got this C0 by doing encryption function with P0. Okay, I've encrypted P0 data, so that's why I got C0. Okay, so I have now C0 value. That C0 will be again encrypted by using the value K. Okay, so after encryption, I will get some value, that is this E represents that encryption of this Cj by using K. This is the meaning for this equation, right? So after that, I got some encrypted format of some value, and that value will be XORed with P, that is plain text of that current one. Now I will get ciphertext. The same will be happened in that decryption part also. Okay, so this is a output feedback function, and this is a last function in the cipher feedback. I mean block cipher modes of operation. This is a last this is the last part, counter. Okay, so counter is here. What is a counter? Instead of using nonce, I can use counter. What is nonce? It's a randomic number or a randomic data. Instead of using that nonce function, I will use some counter function. Okay, so what is the difference between nonce and counter is, in that nonce we have seen the encrypted non will become the input for the second one. But here in counter, all will be independently working. All will be working independently, right? So here the counter one is encrypted. This counter one may have some value. That value has been encrypted by using the key. So after encryption, I will get some output. I mean, by using that output, I can perform XOR function. Sorry, I can perform XOR function for both P1 by combining P1 and encrypted data. Okay, so after that XOR function, I will get my ciphertext. This is the counter one, and for counter two, till how many counters? That counters may be differ based on our needs. Based on our needs, the counter will be differs, right? So this is known as counter. Okay. At last, we can combine all the C1, C2, C3 to get a final output, right? So what are the disadvantages? I mean, what are the advantages of these modes of operation? First one is hardware efficiency. The efficiency of a hardware will be, the efficiency. For example, if our configuration, the lowest configuration is enough for this operation. No need to get some new upgraded, new higher configuration laptops or higher configuration systems. For this operations or for this block cipher functions, only lower configuration will be enough. And also software efficiency, pre-processing, random access, provable security. This is comparing to any of the algorithms, any of the new algorithms or any of the old algorithms. This is a very much highly secured algorithm. That's why we are using this algorithm for online transactions, etc. like that. And it has some simplicity functions also. The functions are more simple. Okay, the functions are easily understandable. It is a more simple function. So these are some of the advantages of block ciphers. Disk. Okay, so as of now, our disk function is completed, right? So we have seen the general, we have started with the general structure of disk, and also round one, and also for substitution. So we have seen some three important diagrams in that disk function. So after that, so what are the possibilities? What are the possibilities to break that disk? That is cryptanalysis. We have two types of cryptanalysis. One is differential and another one is linear. And what is the designing principle we have used in the disk? We have three critical aspects. Three design principles. So first one is rounds. Second one is key scheduling, and one more is functions we have used. So what are the functions we are using in this disk? One is what is that? Permutation, and another one is substitution. Okay, so these we have seen these concepts under the designing principles of cipher mode, right? So after that, we have seen modes of operation, block cipher modes of operation, and there we have 5 types. So first one is what is the first one? Electronic codebook. Second one is cipher feedback chaining. Third one is Cipher feedback. Yes, cipher feedback. And the fourth one is output feedback. And the last one is counter. Okay. So by now our dysfunction is gets over. We have some two important questions here. One is general function of disk. So explain, they'll ask like explain functions of disk, explain disk algorithm like that. Another question is explain block cipher modes of operation. This is another important question. And we have seen some important 2 mark also here. That is avalanche effect. What is avalanche effect? If there is any change in that plain text and if there is any change in that how to say any change in that key, if there is any, yeah, key. Okay, so it resembles into that cipher text. Okay, so this is a very important 2 mark. Okay, okay. Any doubts?
No, sir.
Yes, any doubts? No.
Not
No,
out,
sir.
sir.
என்ன ஓகே என்னையா கிளாஸ்ல எதுவுமே டவுட்டே வரல, எல்லாம் புரிஞ்சிச்சு. டவுட் வரலன்னா ரெண்டு விஷயம், ஒன்னு எல்லாமே புரிஞ்சிச்சு, இல்லைன்னா கிளாஸே அட்டன் பண்ணல. இதுல ரெண்டுல நான் எது எடுத்துக்கலாம்? கிளாஸ் முடிஞ்சிச்சு, கொஞ்சம் ஃப்ரீயா பேசுங்க. அடுத்த கிளாஸுக்கு போகணுமோ? Okay, so two things I want to tell you. It's not based on class. Okay, attendance is very much important. Yesterday your attendance is too low comparing to our remaining classes. Yesterday was too low attendance. Okay, I don't know what happened. 2 hourலயே வந்து உங்க நெட் பேக் தீந்துருச்சானு எனக்கு தெரியல. Right. Okay, so attendance is very much important. Number 1. Number 2, quiz. நான் ஏதாவது குவிஸ் ஒன்று போஸ்ட் பண்றோம் அப்படின்னா அதுக்கு எல்லாருமே வந்துட்டு ஆன்சர் பண்ணியிருக்கணும். ஓகே, ஸோ ஆஸ் பர் அண்ணா யூனிவர்சிட்டி plan, as per Anna University academic schedule, so this attendance will be taken into consideration, and also this is also taken into consideration for your internal marks. Okay, so I need a proof to put some more internal marks to you people, right? எனக்கு போடணும்னு ஆசை தான், உங்களுக்குலாம் இன்டர்னல் மார்க் நிறைய போடணும்னு ஆசை தான், பட் ஐ நீட் அ ப்ரூஃப் ஃபார் தட். ஓகே, ஸோ யாராவது என்னை வந்து இப்போ இவனுக்கு வந்து ஏன் இவ்வளவு மார்க் போட்டீங்க அப்படின்னா, ஸோ ஹி ஜஸ்ட் அட்டெண்டட் ஆல் மை செஷன்ஸ், ஹி ஜஸ்ட் அட்டெண்டட் ஆல் மை குவிஸ் ஃபங்க்ஷன் குவிசஸ் அண்ட் ஹி சப்மிட்டட் ஆல் ஹிஸ் அசைன்மெண்ட் அப்படின்னு நான் சொல்லணும். ஸோ ஐ ஜஸ்ட் நீட் டு ஷோ தெம் அ ப்ரூஃப், ரைட்? ஸோ ஃபார் தட் யூ மஸ்ட் ஒர்க். உங்களை நான் பெருசா டைட்டா எந்த வேலையுமே செய்ய சொல்லலை, ரைட்? ஸோ குவிஸ் என்ன 10 கொஸ்டின் கேட்டிருப்போம், அந்த 10 கொஸ்டினுமே இப்போ நம்ம ப்ரெசென்ட் பண்ண 10 கொஸ்டின்ஸ் கேட்டிருப்போம், ரைட்? அண்ட் அசைன்மெண்ட் ஆல்சோ வீக்லி ஒரு அசைன்மெண்ட் தான் கேட்க போறோம், அதிகமாக கேட்க போறது இல்லை. வீக்லி 1 அசைன்மெண்ட் தான் கேட்க போறோம், 1 or 2 கேட்க போறோம், சரியா? ஸோ அதுவுமே வந்து உங்களுக்கு சிம்பிளா தான் இருக்கும். ப்ராப்ளம்ஸ் எல்லாமே சிம்பிளா சால்வ் பண்ற மாதிரி தான் அசைன்மெண்ட்ஸ் கொடுத்துருப்போம், ரைட்? ஸோ லுக் இன்டு இட், ரைட்? ஸோ நான் வார்ன் பண்ணணும் அப்படிங்கிற அளவுக்கு இன்னைக்கு இன்னும் ஸ்கூல் பசங்களோ சின்ன குழந்தைங்களோ இல்லை. ஸோ யூ ஆர் அ ஃபைனல் இயர் ஸ்டூடெண்ட்ஸ். ஐ திங்க் you are somewhat matured, right? So don't make me to warn you, right? It's just a simple suggestion. Okay, can we really know? அருணாச்சலம் மட்டும் அன்மியூட் பண்ணிட்டே இருக்கான், என்ன விஷயம்? ஓகே, ஸோ அட்டெண்டன்ஸ் எல்லாம் மார்க் பண்ணிட்டீங்களா? யாராவது மார்க் பண்ணீங்க இப்போ உடனே மார்க் பண்ணிடுங்க, சரியா? Within 5 minutes, you just mark your attendance. After that, will be closed, right? Okay, thank you. See you again. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.